Gruesa. Well, that's the way we say hello in Switzerland. Hello, children. How are you people doing? I'm Saurabhkumardutt, and I'm here to teach you people a little bit of mathematics. Now, children, today we are going to pick up Pythagoras Theorem and try and understand what this theorem is. Let us say that we have a right angle triangle, and in the right angle triangle, let us say that we talk about the largest side square, then it is equal to sum of the squares of the other two sides, right? So here now we have this triangle which can be named to be ABC, and now in this triangle we're going to talk about the largest side. So the largest side will be the side which is going to be in front of 90 degree. That means the side AC is the largest side, right? And it will be equal to sum of the squares of the other two sides. As such, here we will have AC square to be equal to AB square plus BC square, right? And this, children, is what the Pythagoras theorem is. So I'll just quickly discuss this once more. Let us say that we have a right angle triangle. That means a triangle which has one of the angles to be 90 degree. Now the side which is in front of this angle, which is 90 degree, will be the largest side of this triangle, because the side which is opposite to the largest angle in a triangle is the largest side. Now the Pythagoras theorem tells this that if there is a right angle triangle, then the largest side squared is equal to sum of the squares of the other two sides, right? That is, here we have AC square, which will be equal to sum of the squares of AB square and BC square, right? So this, children, is what the Pythagoras theorem is. Now here we will quickly be discussing two sums with it. One will be a simple sum and the other will be a little tough sum, right? Now, children, if you want to have a good idea about different topics in which you normally stumble, I'm sure you should here be visiting the app from the Google apps, that is the Play Store, the Mathematics Helpline. I'm sure that is really going to help you in many topics where you find it to be difficult, and with the help of the courses which are there, that is in the Mathematics Helpline, you will have benefited a lot. So make sure to visit it and to clear your doubts there. Now, children, here we are going to talk about first a sum on Pythagoras theorem. So let us say that this is the first sum that I have to discuss with you people. So I'll give you people a little bit of time for trial, after which I will be discussing the sum with you people. Right, children, now let's discuss the question. In the question, we've been given here that there is a triangle whose sides are in the ratio of 3:4:5, and you have to prove that the triangle is a right angle triangle. So here first what we do is, let us consider that the sides are, say, some 3x, 4x and 5x. Next, now if they are to be the sides of a right angle triangle, then obviously the Pythagoras theorem should apply. That is, the largest side square, or in other words the hypotenuse square, should be equal to sum of the squares of the other two sides, that is, one being the perpendicular and the other being the base, right? So this is the theorem which should be applicable. Now here, children, we can see that the largest side is actually 5x, right? So as such, here we will write 5x whole square, which should be equal to 3x whole square plus 4x whole square. Now if we try to solve this, this is going to become equal to 25x square, which will become equal to 9x square plus 16x square. Now further, if we add the like terms of the right hand side, we will get to 25x square, which is exactly the same as the left hand side, which is 25x square. And therefore this shows that this triangle whose sides are in the ratio of 3:4:5 is indeed a right angle triangle. So you will say that the triangle is right angled, right? Now, children, I will quickly be discussing this sum once more, so that if there is any doubt, all of that will get cleared. Now children, in the question you've been given here that there is a triangle, and in the triangle the sides are in the ratio of 3:4:5, and you have to prove that the triangle is right angled triangle. So here we have considered x to be the common ratio, right? As such, the sides now will become 3x, 4x and 5x. So as the hypotenuse squared is equal to sum of the squares of the other two sides, one being the perpendicular and the other being the base. So that's why h square will become equal to p square plus b square. Now as the largest side here can be seen as 5x, so what we do is we will write 5x whole squared to be equal to 3x squared plus 4x square. Now 3x square, children, will become equal to 9x square, and 4x square will become equal to 16x square. And the sum of 9x square and 16x square will become equal to 25x square. As such, 25x square will become equal to 25x square, and this shows that they are indeed the sides of a right angle triangle, because the largest side square is equal to the sum of the squares of the other two sides, right? So by Pythagoras theorem, we've been able to prove this. I'm sure all of you people must be clear about this. Major B? For sure? Good. Now children, after this I have another sum for you people, and I'd like you people to quickly give it a try, after which I'll be discussing the sum with you people. Right. Now let's discuss the sum. In the question you've been given that there is a triangle ABC. A perpendicular is dropped from the vertex A to E. So let us first form a right angle triangle, right? Now let us say that we have a triangle to be, say, something like this. This be, say, one of the sides, and then further we draw the other sides. This, say, is another side. And as we've been given any triangle, so let us consider this vertical that we've drawn to be now the perpendicular that we'll be requiring, right? Now further what we do is we will now be making the other side of the triangle, and let us say that this be the other side. And now children, we'll be talking about making the base of this triangle. So let us say now that this straight line is the base of the triangle, right? So this, children, will now become the triangle. After we have the triangle, next now what we do is we will now be talking about naming the vertices, as the name of the triangle is ABC. So as such, we will name it to be A, B and C. And further guys, you've been given here that there is a perpendicular which is dropped from the top vertex A to E. That is, the foot of the perpendicular can be marked to be E. Next now, we've been given here that D is the midpoint of the side BC. So what we do is we consider a point approximately to be the midpoint of the side BC, right? And we mark it, say, something like this, with another straight line. And let us say now that we have this to be, say, somewhere here, right? So this, say, is the midpoint, right? And as we've been given here in the question, it has to be marked to be D, right? So now we can easily understand one thing here, that is the length from D to C. If suppose it is some x, then obviously the length from B to D is also going to be that same length, that is x, right? And as here E is the foot of the perpendicular, so we require to make an angle of 90 degrees here. And now children, we've got to prove this, that AC square is equal to AD square plus BC dot DE, right, plus 1 by 4 BC square. Remember, this dot means that there is a multiplication sign. So next now we talk about discussing the sum. So here first what we're going to do is we will now be talking about the three right angle triangles that we have. That is, the first right angle triangle is ABE. Now we will say in triangle ABE, As you see that AB is going to be the hypotenuse, so AB square will become equal to AE square plus BE square. This, guys, is going to become the first equation, and obviously this is by the Pythagoras theorem. Next, children, we will talk about the next right angle triangle. The next right angle triangle is AED. So we will talk about triangle AED, and in that what you have is, we have here the hypotenuse to be AD, and its square will be equal to sum of the squares of the other sides, that is AE, the perpendicular square, plus the base, which is ED squared, right? So this, guys, is going to become the second equation. Now we talk about the third equation, and for that we will be choosing the third triangle, that is in triangle AEC, right? Now in this triangle, children, what do we have? We have the hypotenuse to be AC, so as such AC square will become equal to here AE square, which is the perpendicular, plus we have EC square, which will become the base squared. So this, guys, is going to become the third equation. Now as we require AC square, so we will be picking up here the third equation that we've made, that is here the third equation, which is AC square is equal to AE square plus EC square is going to be picked up. Now remember, what we require on the right hand side is AD square, right? And as you can see, AD square is there in the second equation. So now we're going to use the second equation, and now we will be keeping here the value of AE square, right? So now we use the second equation. So we will say now using equation number 2, and that is our step, and we will be writing the value of AE square as AE square can be written as AD square minus ED square. So we write that now, that is AC square will become equal to the value of AE square, that is AD square minus ED square, right? And to that, children, is added EC square, and for the time being we will let it remain to be as it is. Now next, let's quickly check about what all we require. We require AD square, and we have it. We require DE, which is the same as ED, so we also have it. And further after that, we also require BC, right, which is the whole base, right? So here as such, what we can talk about is, we can talk about EC. I'm sure you can see EC, right? EC is all of this length, right? And EC can be written in the form of ED, which is the same as DE plus DC, right? So ED plus DC. AD square minus ED square, we let it remain to be as it is, and now we keep the value of EC. Remember, EC was ED plus DC. So ED plus DC, and there's also a square of it, so that's why we square it too. Now further, guys, this becomes equal to AD square, right, minus we have ED square, and now we can expand the whole square. This is going to become equal to ED square, plus it'll become equal to DC square, plus we will have 2 times of ED multiplied with DC. Now further here, we get to see that ED square will get cancelled with ED square because one is in positive and the other is in negative. Then further we are left out with AD square, right? And to that is added DC square. Now remember, children, that D is the midpoint of the side length BC. As such, you can talk about DC to be equal to half BC, and this is what we're going to write here. That is, we will now be writing DC to be equal to half BC, right? And then we also have to square it as there is DC square. Next now, children, we have 2 times of ED, which is going to be written as it is. And like we have written DC as half BC, we will write that same here. Now here children, 2 will get cancelled with 2 as both of these are in multiplication, and as such here in the next step you can write this as AD square plus 1 upon 4 BC square, right? On squaring it, 1 upon 2 will become equal to 1 upon 4 and BC will become BC square, and to that is added here DE, which is the same as ED, and dot BC, that is multiplied with BC, and I think this is what had to be brought, that is AD square plus BC dot DE, AD square plus BC dot DE plus 1 by 4 BC square, and thus children we can say that this stands to be proved, right? So I'll just quickly discuss this all over. In the question we've been given here that we have to prove in a triangle ABC where from the top vertex A, if a perpendicular is dropped to the point E and DB the midpoint of the base BC, then BD, if suppose its length is X, then DC, its length would also be X because D is the midpoint, right? So here now further we've been told here that we have to prove AC square to be equal to AD square plus BC dot DE plus 1 by 4 BC square. As such, now here what we do is we now talk about 3 right angle triangles that we have and apply Pythagoras theorem for it. One right angle triangle is ABE, and for that we can say AB square is equal to AE square plus BE square, right? That is AB square is the hypotenuse and its square will be equal to sum of the squares of the other two sides, right? Next children, we talk about the triangle AED, and in that we know that AD is the hypotenuse, so AD square will become equal to AE square plus ED square, right? Next, we have the third right angle triangle, that is AEC, and in that we see that in front of 90 degree AC is the hypotenuse. As such, AC square will become equal to AE square plus EC square, right? So these are the 3 equations which are possible by applying Pythagoras theorem. Now, as in what we've got to prove, we require AC square, so we pick up the third equation which has AC square, and now we move on to the right hand side and try and prove this. So now further, as it is equal to AE square plus EC square, and AE is the common perpendicular that we are talking about in all of these 3 equations, so we can substitute its value. Now remember children, we require AD square, and AD square is there in the second equation. So next now we pick up the second equation and we keep the value of AE square to be AD square minus ED square. So AD square minus ED square is what is kept, and after that children we have added to this EC square, so we let it remain to be as it is for the time being. Further, we turn our attention towards EC, as EC can be written to be ED plus DC, so that is what we write here. Now, as this is a binomial whole square, so obviously we can expand this as A square plus B square plus 2AB. Now further, we have minus ED square and plus ED square, which both cancel each other. And further here, if you talk about DC, D being the midpoint can be set, DC can be said to be half BC. So that's why here we have half BC, right, which is the value of DC, and then we square it, which will become equal to 1 by 4 BC square, right? After that children, next now we talk about the last term, which is we have 2 times of ED into DC. Now remember children, DC is the same as half BC as we substituted in the last step, so we keep it to be half BC. 2 and 2 get cancelled as they are in multiplication, and you're just left out with ED into BC. Now remember, ED is the same as DE, so we write it as plus DE into BC, and if we check, all that we have is what we require, that is AD square plus 1 by 4 BC square plus 1 by 4 BC square plus BC dot DE plus BC dot DE, and therefore children, this stands to be proved, and I'm sure all of you people must be perfectly clear about this. Sharmila, are you clear? For sure? That's good. I'm sure children, this lecture in Pythagoras theorem must be perfectly clear with you people, and now you people are going to bounce back in your books, quickly search for this topic Pythagoras theorem and do good practice in it. So make sure, children, today you repeat the same sum that we've done here in class, right? Normally I call it the CWDA, that is class work done again. And after that, you can go to your book and try out more sums, and I'm sure you will make this topic really strong. If suppose you have more sums and topics in which you want me to make lectures, make sure to write it in comments. And except that, I'm sure you should visit the Mathematics Helpline from the App Store in Google Play Store, right? Where you will get momentous amount of help in the topics that you normally stumble in. So make sure, children, you give me a resounding response to this. If you really understood this, make sure that you like it, and do pass this on by sharing this to the children who really require it. And here then, do practice and make maths your strongest subject. Bye, children. Have a nice time.